Yeah, I think that people, in general, people have a belief that computers are magic. And the thing that really bugs me, the thing that really gets me, and is part of the loneliness factor of programming, is the moment that you start talking about a computer, people tune out because they're like, oh, it's impossible to understand, I can never get it. It's like math, I can't even add 1 + 2. Like, no, you can't understand this. Like, literally, you make decisions on a daily basis of how to live your life. You get up in the morning and you have to choose cereal. And that involves logical steps, like opening the pantry door, reaching for the cereal box. Like, these are instructions.
I totally agree, yeah. And even if you just talk about, like, assembling a computer, people will be like, oh, that's crazy. And I'm like, it's just putting screws in, like,
Yeah.
you're just screwing stuff together. Some of it just snaps in, like.
Back in the 90s, it was a little more complicated. You had to read the manual because you needed to make sure that if ISA Gloss 2 and 3 shared IRQ 7 and 9, that you put your audio card in ISA 1, unless your video card needed ISA 1, in which case the audio card had to go in ISA 4. But then, your other stuff could go into ISA 2 and 3.
Okay, well, that was before my time.
Same.
Yeah.
In my day, it's been easy. Like, I watched a YouTube video on how to do it, and I did it.
Yeah,
I haven't done it.
Yeah, there's by the time I was finishing high school, all of that almost had gone completely away. There was still a little bit where you have to go into your BIOS and set your clock speed if you bought like a value brand RAM and an AMD processor.
I think I have done that before. I would just like set my RAM speed to be the speed that it's advertised to be. Because sometimes by default on older machines, it would just set it to be like 2133 megahertz or something, even if it could go up 3200 or something. Although I think nowadays, if you're like on the most recent AMD, it will, when you first build it, it will like keep resetting, like it will reset itself like 9 times to figure out the optimal configuration for your RAM. And so yeah, nowadays that's automatic too. You don't even have to do that. Everything's easier nowadays.
I think my second computer, I bought a gaming motherboard and it didn't have a default clock speed. And if you set the clock speed wrong, it could, fry your CPU. So like you're greeted with this option of, what clock speed do you want? And there's multiple ways to get to, 1.2 gigahertz. But most of the time it wasn't too bad. You just took the battery out, the CMOS battery out, and put it back in. You got the wrong option.
Did you have to wait like 15 minutes for the reset?
No, it's 3 seconds. Yeah, there was also a time when they had not yet put the notch in hard drives. That was probably back in the 80s. But, well, now the connector is very, very different. But it used to be a rectangular connector. And if you plugged it in backwards, it would fry the hard drive. But there was often no indicator of which way was backwards.
And there's a little red stripe on the side of the ribbon cable, and you had to look on the motherboard, the little PCB board, and sometimes they'd have an indicator of where pin 1 should be, and sometimes there wasn't.
Yeah, but then later they just took one of the ground pins and filled it in solid so that if you tried to plug it in, the only way you could do it is if you broke the other pin, which is preferable.
Yeah.
It's a little easier to fix.
Well, you can't really do it wrong unless you really try.
But
You're like, oh, I'm good at force.
well, okay, what if I've been able to get it backwards? There's something. I think I was able to get a Thunderbolt connector in backwards. They seem like they should only go in one way, but it's not true. They'll go in either way. Like when they get worn, because it's just a more rounded edge on one side. And so after you've plugged it and unplugged it 1,000 times, it'll go in backwards.
Oh, interesting.
Yeah.
I've still never used Thunderbolt.
Well, now you do. You just don't know it's Thunderbolt anymore. All right.
Are we live?
Yeah, I've been streaming with the counter, the tick down counter.
Oh, so fun.
Yeah, just for the last 5 minutes.
Love it.
Yeah, so, but it's all been your face and us talking.
Yes.
So there might be some slight misrepresentation going on.
Yeah. Maybe I'm just really good at ventriloquy. I can sound like many people without really looking like it.
Maybe you can. Maybe we should find out.
Nope, I definitely cannot.
Okay, well, I'll go ahead and post the link for the people that are interested in that.
Cool. Oh boy. We're getting started.
How do I... What? A pop-up. I just... Go away, pop-up. Okay, maybe later. Okay.
Pop-ups are the worst.
You know, Loris Crow has been railed against that kind of thing, the maybe later dialogue.
But just let me click away from the pop-up and make the pop-up go away. Like the old days. The good old days. Ugh, I'm never going to make it.
Sometimes I'll hit the X before I even read it. And sometimes I actually did want to see what it said.
Yep.
But I hit the X so quickly.
We're
that
just
I'm like,
conditioned.
Yeah, I know.
It's kind of like, I think the term's like banner blindness, for being like just ignoring banners on web pages because we're just so used to ignoring them.
Well, that's what my wife does. She'll literally install a new program, and then it'll ask something like, "Did you want to allow Zoom to access your camera?" And she'll just click cancel. And she's like, "Zoom won't work on my computer." Like,
Yeah.
did you literally install Zoom and then click cancel during the install?
You know, I think I did that recently with setting up my work laptop. I had to go in and set it up. It's like, ah.
I actually did have one time, I was reading on a website, and there was this big red text, and I just skipped over it, and I start reading the fine print, and then the fine print, it's like, apparently people don't see big red text anymore, and I'm like, wait, let me look it up again, and I'm like, oh, okay. Like, yeah, I just completely ignored it, because, you know, I'm looking for real information, not the headline.
Yeah. Well, I mean, the most important thing is that Utah drivers are learning this one weird trick, and they'll never eat bananas again.
Alrighty.
That's, I think, the important bit. Okay, cool. Well,
Are we ready?
We're ready now.
Okie dokie.
I'm going to go ahead and turn off the countdown timer. Boom, countdown timer's turned on. With that, I want to give a warm welcome to everybody for coming to Utah Zig. Yet, once again, you have made good choices in your life, and you will be justly rewarded by our great Ziguana above.
Thank you.
Amen.
What's that scene from Dude, Where's My Car? Where they're like,
Don't know.
ah!
My mother wouldn't let me watch that movie, so.
I've never even heard of it.
Well, you can watch it now.
Yeah.
I mean, it's not as good when you're like more than 50. But it was awesome at the time. Anyway, so welcome out. Thanks to our sponsor, Vivint, for giving us a place to meet and some pizza to eat. And some job opportunities in various languages. Soon to be Rust, I hear. Actually, I haven't heard that yet.
I mean, we've had Rust positions. I don't know if we have any right now. But
Did I say Zig?
The embedded team
you
does.
use Rust, but the,
Oh, I meant Zig. Sorry.
Possible Zig, who knows?
I was just talking to, yeah, anyway. Well, right.
I think we're gonna have some Scala positions soon, which is none of the languages that
Wow.
are up here.
All right.
Oh, yeah, you said that last time.
Well, thanks to Jeff for making this all possible through Vivint.
Thank you,
And
Jeff.
then thanks to
Nathan Craddock.
Yeah.
Nathan
Yeah.
Doomslug for
Yes.
preparing the presentation tonight. And with that,
Happy to share.
we will give it away to you.
Alrighty. So yeah, I'm going to talk about Reckless Drivin, which is a shareware game, a shareware Macintosh game from the year 2000. And for the last 4 years, off and on, I've been rewriting it. Started with C, and then in 2022, and I picked up Zig, I switched to Zig. So it's just a tiny bit about me. I work as a software engineer. I love code, which would kind of be obvious there. I love making pizza, so it's wonderful to eat pizza here. I also
wow.
love hiking these beautiful mountains here. And everything I'm going to share today has basically already been shared on my website. So if you ever want to see it in more detail, there's some links, and then there's a link to the GitHub repo where all the code is. So
And when you say you're a software engineer,
Yeah.
what does that mean?
Oh,
What do you do?
that's my job title. I write code. I work for Nectar. So,
What do you do?
What do you mean?
Well, I mean, like, what kind of code do you write?
Okay, so write code in JavaScript, TypeScript, Vue. Just started like last week. So
Oh, okay.
I was at Qualtrics before.
Okay.
Yeah.
So it's web-based something, something?
Yeah, web development. Not as cool as Zig, but it's fun.
Okay.
Good people. So, we're going to talk about Zig. Oh, my animations. Okay. And, because that's what we're here.
I think that it shows up correctly here, but the TV doesn't.
No, it's actually fine. My laptop
Oh.
was actually the wrong one, which is really
Oh,
weird.
okay, okay.
And we're talking about games because it's rewriting a game. Carbon, so like Mac OS APIs that are deprecated. So that'll be kind of fun. Not
Wait,
very
wait.
useful knowledge.
So literally, OS 9
Yeah.
Carbon
Yeah.
is still available today?
No.
Okay.
But the game was written for it, so I have to understand the system calls to re-implement the game.
Okay, yeah, because I think that we've had 2 or 3 different operating system kits, SDKs.
Yeah, it was like
since
Carbon, Cocoa, AppKit, all the frameworks and Foundation, all the stuff.
Okay, you know about it. I don't really know about it. But
Okay, so, and reversing. So let's
Reversing.
just jump into Reckless Drivin. So,
what's reversing?
like reverse engineering.
Oh, okay.
Yeah.
That's what
So,
the kids are calling it.
yeah,
Yeah, you've been on TikTok recently.
I'm definitely.
Wait, programmers are on TikTok?
I'm just making a joke.
So this is the menu screen for Reckless Driving. And as you can see, it's got some homemade charm to it. We love it. Nice little font. The buttons are all license plates. In the bottom left it says Burning Rubber 2, because the guy who made the game, Jonas Echterhoff, who I think is actually German, so it's probably Jonas, but he wrote a game called Burning Rubber and then made a second game, Reckless Driving, and it's basically the sequel to Burning Rubber.
That is so cool.
And it's a fun little top-down racing game.
At first I thought those were handlebars for a motorcycle, and then I realized it's a car upside down.
Yep, it's an upside down car. And so this little picture I got through my work on the game. So like this is a picture I got through the Zig code, which is kind of cool.
That's awesome.
So he worked on the game for a couple of years, and then after Mac, the APIs were deprecated, he discontinued it, but he just left the game up for free. So the website's still there. Hasn't been changed since 2009 as far as I can tell. But it's a fun little game. And here's just a little glimpse of like the help menu, so you can see more of what the game actually looks like. So you're driving a car top down. It's got some really nice, actually really, really good handling for the car physics. It's got really good, all the roads and the cars will have different friction variables and handling, so it feels very realistic when you're actually playing the game. And your entire goal is to just drive as fast as you can and do as much damage as possible without being pushed off the road by the cops.
Oh, wow. Oh, wow. I think I want to play this.
Yeah, I want to play it again too. And so Jonas, he went to work on another game called Redline, which I actually played in junior high, which was kind of fun. I didn't realize that until later. And now he works for Unity. So, pretty cool. And there's the link to the game's website. So I'm going to really quick, before we jump into more stuff, demo how far I've gotten in my rewrite, which isn't incredibly impressive, but hopefully once we dig into some of the code and stuff, this will actually be pretty impressive. So far I have the backgrounds drawing, which involves drawing the backgrounds, the roads, the tracks. They're all drawn separately. And that's all running in Zig and using Raylib for windowing.
Using what?
Raylib. It's like a
Raylib.
library for making games.
Like ray of light?
Yeah, RAYLIB. And I don't remember why it's called Ray, but it might be the person's name who made it. But yeah, so that's as far as I've gotten. Not too far, but yeah, let's jump into a bit more, just a little bit. So what we're going to do for the next little bit is just talk a bit more about some context and background for the game, some of my early efforts in rewriting it in C, and then we'll jump into the Zig stuff. So why am I even doing this? Well, my dad had this laptop for work back when I was but a wee lad. This PowerBook G4 laptop running PowerPC.
Nice.
And he installed Reckless Drivin, this game on it, the shareware game. And so then I played Reckless Drivin on his work laptop when he let me. And I loved it. It was super fun. I can still hear the sound effects of the game in my head, and I'm excited to hear them in my version eventually. But with things, the laptop eventually had to go. It got too old, stopped working, got to get a new work laptop. So I really haven't played the game since then, which is unfortunate.
Did you know that there is a virtual machine tool for the M1s that will run OS 9?
Yes, I've tried it. QEMU and I'm trying to remember what it's called.
UTM,
Yeah,
Universal
UTM,
Turing
yeah.
Machine.
Yeah, I've used that.
No one has stated that that's what it stands for, but dollars to donuts, it's Universal Turing Machine.
Cool. So, middle of 2020, that COVID summer, I was really bored, out of my mind, and I remembered the game, and I thought, how hard would it be to decompile this game and rewrite it? Because there's no source code available. And so I tried, and that was really hard. But then I decided to do a bit more research and realized that Jonas had uploaded the source code for Reckless Drivin the summer before to his GitHub repo. And it's just a bunch of C code, pretty messy, with a lot of Mac Carbon API calls. So it's not something you could just download and compile right away. It used an IDE, I don't even know if that was the terminology at the time, called Code Warrior to build the code. So, yeah. And it's also missing a lot of source files, too. So it wasn't a full dump of the code. So I grabbed the Git repo and decided I wanted to rewrite it for modern operating systems. And as you just mentioned, emulators, I felt it'd be more fun to rewrite it rather than just emulate the game. And I've also tried a handful of emulators and the game crashes in it. I'm sure, from what I've heard, there are some emulators that can run the game. I just haven't bothered because I want to play the game with my rewrite and not through an emulator. It just feels more right to me. But at the time, I hadn't learned of Zig yet. This was 2020, and I didn't learn of Zig till 2021. So I started with C and CMake. And so let's talk about the game asset storage. So this is like all of the game sprites and the backgrounds and the sounds and the loading screens, all the stuff. So have any of you heard of a resource fork before?
I have oft wondered what it means. It's something to do with the file system.
Yeah, this was actually really cool to me. I didn't know about this at all until I started working on this project. So when Jonas uploaded the source code, his README in GitHub says, to be able to upload this to Git, the resource forks of the resource files have been moved to the data fork. So a fork is a set of data associated with a file. On the Macintosh, I think it's the HFS, hierarchical file system, they supported each file has a data fork that we're all familiar with. That's like the data you read and write to a file when you're using programming languages and you're just using your normal software. But a resource fork is, you could almost think of it as like a separate partition in a file, where it's bundled with the file, but you don't typically see it. And so each file on the Mac has a resource fork, where executables typically would store data like icons, color tables, cursors, pictures, text, menus, all sorts of stuff. And it's almost like a key value lookup, where the application can say, give me the resource under this ID and this name. And then it'll give you the bytes for that resource. So it's pretty cool. It allows you to bundle resources with an application. It's not used anymore, but because of like backwards compatibility, you can actually still access resource forks on modern, more recent Mac file systems. So I do have a little demo for that because I think it's kind of cool. So
The only reason I know about it is because I used to get errors.
Okay.
Cannot delete file while resource fork in use or something like that.
Yeah, this is all before my time, so I've never seen errors like that. I've just had to learn about this through Googling, and it's not great to Google this stuff because it doesn't get used anymore, so it doesn't show up in the results.
Yeah.
But I have a file named A and a file named B, and B says, hello everyone. And what I'm going to do is just run this command. On Mac, with the ls command, if you add the @ flag, it just outputs any special Apple data, metadata associated with the file.
Oh, wow.
So if we do copy, and then I'll do, I gotta remember what this one is, RS. Yeah, there we go. Oh, look at that. You can see my Avatar: The Last Airbender when I was ripping it off my DVDs. This is what we want right here. So we're gonna copy the contents of B into A, and then you go to named fork, and then resource. And this is going to copy the contents of B, which is just me saying, hello everyone, into the resource fork of the file A. So then if we do this again, we can see that there's now 19 bytes in the resource fork of file A. Kind of weird. But if I were to like output the file A, there's still no data in the data fork. It's only in the resource fork.
So, named fork is a special keyword.
Yeah.
Okay, so // named fork is a special keyword, and then anything that comes after that is something about that. So that's happening. That's happening at the file system layer.
That's my understanding.
And then they have a special version of LS that's proprietary to Mac.
Yep, that can read these kind of things. And so that's why Jonas said he had to convert the resource fork into a data fork to be able to upload it to Git and GitHub, because Git doesn't track resources. It only tracks the data.
Well, that's too bad.
Yeah. So pretty interesting stuff. And so I had to figure all this out. So I'll jump back into this. And so when the GitHub repo from Jonas just had a file called data, just a big binary opaque blob, and that had all the resources in it. So like this is a piece of code from the original source code for Reckless Drivin. Get resource is a Carbon Mac OS system call, and so get resource picked gets a picture type resource of ID 1000. And so this is actually the loading screen, if I remember correctly, for the game. This is how you get the bytes for the loading screen. And there's a lot of like standardized resource types that are used all across old Mac software, but two that are commonly used in Reckless Drivin are pack and ppick, which as far as I can tell are exclusive to this game. He like made up these own formats. And pack is compressed game data, and ppick is packed picture data. So what I needed to figure out was how to rewrite or re-implement get resource so I could take this blob of binary data in the data file and get it into my game. And so this is a little bit closer look at what's in the resource fork after I was able to unpack it. So the resource fork, just I lost my mouse cursor. Oh well. So the top part has the packs, the ppicks, and the check. So these are the different types of data in the resource fork. And then the ppicks are like the loading screen, the packs are game assets, and check is a little byte used to verify the encryption. Because some of the game levels 4 through 10, are encrypted. Because it was shareware, it was not entirely free. If you paid, you could play all 10 levels, but if you didn't pay, you could only play the demo of levels 1 through 3.
Okay.
So the packs come down to, so pack is like the type, and then these numbers, 128 through 142, and then 143 through 149, those are the IDs in the get resource call. So pack would be the ID or this type, and then the number would be like 128. So if you want to get the sprites, it's pack 128 in this call. And it's actually interesting because this is single quote. So this is actually interpreting this as a character and not a string. It's really interesting.
Mm. So how does it know what file to get it out of? Because you...
Like which file?
Yeah, is it like the binary is running, and so the context of the binary running provides the resource fork?
So like the executable Reckless Drivin bundled in its little Mac OS package. The operating system and everything, like the API knows the executable itself. When you use get resource, it gets the resources of the currently running executable.
How does the string get interpreted as a character?
I honestly don't remember because it's been a couple of years since I looked into that. But I do remember my editor would yell at me.
Like, how does that make sense?
It's an enum, so it's going to be...
No, it's not. Those are single quotes, and so it does convert it to a number, but it's not like an enumeration.
What I'm saying
Oh,
is...
sorry.
What I'm saying is, and correct me if I'm wrong, but the code tool that builds this
Yeah.
knows that syntactically represents something. So if it starts with a single quote, and then it has specifically one of these words from a list of keywords, and then a closing single quote.
I don't think that's how it worked, if I remember right. I think it actually does get converted to a number, and not by the compiler, not in a special case by the compiler. We can look into that later if we want.
This is in C?
Yeah, it's C.
So that the picked is arbitrary.
Yeah, it could be any string.
Oh, okay,
Yeah,
okay.
Yeah,
all right,
yeah,
that's-
yeah. Sorry.
I
See, does it do
understood.
that?
Hmm?
Does normal C let you do that?
You can. It's just warns, if I remember right, because this did work. I did get this working with C eventually.
Oh, so this is
Why?
this isn't a special OS 9 programming language.
Yeah, no, this is C.
Okay.
Yeah.
Okay.
Really, really weird, interesting stuff. So yeah. Oh, and then so yeah, the last few levels are decrypted, and then all the data goes through LZRW decompression, which is a decompression algorithm that isn't used anymore. So what I did, because I didn't really know how to look things up super well at the time, and I didn't really know what I was looking for, but I came across this tool called DRes, and if you install the macOS developer tools, you'll have this. And it stands for decompiling resources. And so I just passed the data file to DRes using the flag useDF to say, hey, this is a data fork, not a resource fork, because data is the resources moved to a data fork, and then it just outputs it as plain text. So you can see right there, it kind of looks like the output of XXD if you've ever used that program. It just shows the bytes and then an ASCII interpretation on the right if it has an ASCII representation. And so what I did with this was I took this and then wrote a Python script to reinterpret this data back into binary in a format I understood. And I've since found documentation for the resource fork format, so I could do this in a better way eventually, but what I have now works well enough. But basically the way I stored it is a header that has a resource type, which is like the pack or the picked or something like that. The ID, which is the number. So in this case, the type is pack, and then the ID is 128, and then the length, which just tells me how many bytes follow. So then a resource is just a header followed by data. So at this point, now I had a way, and I'm using the Zig syntax here for structs, but I did this in C first. But I figured since this is a Zig meetup, I'll use the Zig syntax. It's similar enough either way though. So once I had the Python script working and I had my data in a new format I understood, I could write some C code to pull out resources.
What? Remind me what extern is again.
C compatible.
Oh, okay.
Yeah.
It's a C compatible
Yeah.
struct.
And it also prevents it from like reordering the
Which, by the way,
fields.
are you allowed to have that 8-byte array inside of an external struct?
It works.
It works.
Yeah.
I feel like there was something that you were allowed.
Maybe it's packed. I think packed structs don't allow it.
Maybe pack. You have to do it a certain way for some reason.
Yeah. So this is the source code in Reckless Drivin that takes the resource data and converts it into a pack that the game can use to draw stuff to the screen. And so given a pack number, and so going back just a tiny bit, that's like pack 128 or pack 129. So any of these 128 through 149, those are all packs. So given a pack number, if it hasn't been loaded yet, it uses getResource to get that pack. And this is my rewrite, so I actually did convert it to use strings in this case with getResource.
Beautiful.
Yeah.
Modern programming.
Much happier.
A real string.
And then after the pack's been loaded, if it wasn't null, so if it worked, if the number is greater than the encrypted, so that is if it's 143 through 149, it will decrypt the data. And then after decrypting, or if it didn't need decryption, it then uses LZRW to decompress the pack. And so when I opened this up, I was like, this is going to take a lot of work. And this is where most of the work for my reimplementation of the game has gone into, is trying to do the decompression and the decryption. So let's talk about, the decompression first. So LZRW, the code that Jonas uploaded to GitHub does not actually include the LZRW decompression code. I don't know if that was like out of concern for licensing reasons or anything, but so I ended up just looking it up, and I eventually found a Wikipedia page for it, and there's 7 variants of this algorithm. And there's no indication as to which was used in the source code, so I just had to try them all until one worked. And this was a super long process, and just because I do actually want to spend time talking about Zig here, I won't go into the full details. But I basically had to just write code that would, the PPICs are QuickTime image format, which is like an older Mac image format, And so I had documentation on the layout of a quick draw format. I had documentation of that, so I knew what the bytes should look like after coming out of decompression. And so,
Did you have one of the images?
no, I found a PDF of imaging with quick draw, and I just knew what the bytes were supposed to look like for like the headers of the image. Because quick draw is not like a bitmap format; it's more like instructions on how to generate an image. It's more like a PDF in that way, where it's like it's interpreted and an image pops out. Luckily for me, all the images are actually bitmaps, but there's still like some header information on like stuff to know.
RGB.
I guess I have a question about LZRW as well.
Yeah.
Do you think that they are similar enough that it makes sense that they all fall under the same name? Or are
Yes.
they completely different?
So they were all made by one person. I think his name's Ross Williams. We can find out. Yeah, Ross Williams. Lempel Ziv Ross Williams. Made by Ross Williams.
Good for him.
Look at that cool guy. From Australia.
So it's based on LZ,
Yeah, so it's like...
which is what's used today.
Yeah, so parts of this are still in use, just not the specific variants of the algorithm.
Well, if you were using his version, you wouldn't have gotten your Linux system owned.
That's true. So yeah, he wrote all the variants, and so I just tried them all one at a time until I finally looked at the output and saw that the bytes were as I expected. And that took a lot of work because there was actually a 4-byte offset I wasn't aware of. So I actually had to decompile the game and look through stuff, and then I found the 4-byte offset, and then it all just worked.
Oh my
So
goodness.
it's LZRW3A, and I go into a lot of details on my website. So it's interesting, but I don't want to take the time to talk about it.
I love the type of coding where you just type stuff in and you're like, did it work? Type more stuff in. And just see
Yep,
it
that was
until it
me
works.
for months.
So, did you have to deal with any of the big Indian, little Indian stuff?
Yes.
That's the worst.
We'll get into that too.
You think you tried every compression algorithm, but you didn't try them backwards.
Yep. And so as I mentioned, levels 4 through 10 are encrypted, but I don't really want to take time about describing how the decryption process works. I've also written about that if you're interested. But.
Oh, wow. Wow.
So that, and like I said, after learning Zig in 2021, I decided to rewrite Reckless Drivin in Zig in 2022 because I just thought it'd be more fun. And so overall, it's been really good. It gives me a lot more safety, a better build system. I love C import, embed file, built-in testing, and compile time metaprogramming. It's just been awesome. So with the rest of this now, I'm just going to go and break these down into specific cases where using Zig has been better than my attempts at using C and CMake for Reckless Drivin. So yeah, safety. Zig basically makes sure I don't mess up in a lot more cases than C. With built-in slices, so pointers associated with lengths, and then all the other pointer types like a C pointer that doesn't have an associated length, and optional pointers. The resource fork data, when I was using CMake, I'll actually talk about that a little bit later, but just trying to actually get the resource data, the binary, embedded in my program when I was using C was a bit trickier. And then there's also just like runtime safety, like integer overflow and bounce checks.
Were you able to use embed file that built in Zig?
In Zig, yeah, that's what I'm using now. Very, very nice. Cross-platform, it's lovely.
Just works.
Yep. So like, as a specific example of safety, when I mentioned storing resource fork data, in C, when I was rewriting in C, I really tried my best to not change the source code as much as I could. I wanted to leave it intact. So in the source code, a pointer type is just a char pointer. And then a handle is a pointer to a pointer. And so it's like a double pointer indirection.
Fun.
And so and then I made my own type called, so PTR pointer is different than pointer the word. So I made my own pointer that, I wish I had my mouse, but it,
I see.
yeah, where basically I stored the size and then a pointer to the data. And so every time I wanted to pass around resources, I was using this get handle size function, which is this is actually a Carbon function that exists, and I just wrote my own version of it because I didn't have access to all the underlying under the hood of the Mac OS 9. And so I just decided to represent pointers this way, where it was a integer size of how many bytes are in the pointer, and then a pointer to that data. So then every time I need to know how big a handle was, I had to pass it to this function where it would do some pointer arithmetic to find out where the previous field in that struct is and then give me the size. It's just kind of really messy, kind of unsafe. If I passed the wrong type of pointer to this, everything would just go catastrophically wrong. And in Zig, I just use a slice. It's so nice.
Was this originally a 32-bit game?
I think so. Like PowerPC, I think would have been 32-bit for sure, as far as I'm aware. So yeah, that's just one really nice thing, and just already off the bat, just a much easier type that just gives me safety and convenience. And then Zig build is just better than CMake. CMake is another language to learn. It's kind of messy. Everything's strings. And like I mentioned, it was hard to get the resource data embedded. I was first using LD, like just a linker, passing in with these flags I found on the internet to take my binary data to output an object file. And it worked for me. I was on Arch Linux at the time. And I was able to pass this pax.o file to CMake, and it would compile it alongside all the files. And it worked great for me. But then I remember someone, I don't remember where, someone reached out to me at some point and said, hey, this doesn't work for me on my computer. And I was like, oh no. So then, so another thing I tried and researched was using XXD with the iflag, which if you've ever used that, it takes the data given and outputs it as a C header file. So that would have worked fine, except the output of that is 5 megabytes, and I don't want to commit that to my repository. And so in Zig, I just use embed file. I give it the path to the data, and it just embeds the binary directly in my code, and it's great. Another thing was just testing with CMake was a lot more painful. Each test had to be like a separate file and had to be added in the CMake setup, and I would usually forget to add it, and then things wouldn't work. Another one is C import. So I'll jump into some code now. The first one, well, first I'll just mention Raylib. Like I said, that's what I'm using for doing my windowing. I'll eventually get to sounds with it and controller inputs, but it's just really nice to be able to reuse existing C code. And then the LZRW3A algorithm. I didn't have to rewrite it. I could just use Zig's C import to take that code and run it. It's just so nice.
So why not have a separate utility, one that can convert the historical data file to a tarball, and then just use the Zig tooling to read the tarball?
So like convert my resource fork into a new format and then
just
pull it in.
Just read them out, put in Atari XZ.
I've thought about it.
Because you're doing the work anyway. Right?
Yeah, like I'd have to, yeah. It does, because the data is compressed already, and I've already gone through all the work to read it all out, it's like, might as well just stick with what I've got. It's also kind of fun to keep the code the way it was, as close in a way. But I could do that. I could take all my in-memory data once it's been unpacked and uncompressed and decrypted, and then dump it back out.
Yeah, you could write a unreckless driving C.
But so I could do that, and it'd be just as efficient. Like, I mean, in a way more efficient. But it's also just kind of fun the way I have it working, and that code works. I don't have to change it anymore. It works.
I get the artistic value.
Yeah.
I'm just thinking posterity.
So, oops, typed Raylib.
Yeah, the next person that rewrites your rewrite.
Oh, that'd be cool. So yeah, with like Raylib, I can just give it the header file, and then I can just, and I'm actually in the middle of a change right now where I was trying to fix the windowing stuff, but I can just use C dot and access any of the Raylib functions. That just makes it super easy. And then I'll jump into the LZRW code, because this, from 1989,
Wow.
and
1989.
this is the header file.
19.
So there's the declaration for the function that does compression, and then the decompression one is, oh wait, sorry, this handles both, because the action specifies which action, decompression or compression. And then there's the C source code, and it's a lot. It's kind of fun though.
A lot of comments though.
Yeah, it's well documented.
Looks like you can probably understand it if you read those.
Yep. There's just a lot of macros that get expanded. It's kind of fun. Like a lot of unrolled.
That's
Like I think this is an
that's
unrolled
beautiful.
loop, I think. It's kind of fun though. It's been fun to dig through it.
Increment
pointer dereference that pulls in from a different, pulls in
Yeah.
from it.
So I don't want to rewrite this. I don't want to spend my time rewriting this. So it's really nice that I can just do LZRW zig, pull in the header file, and then I can just make my own decompress wrapper around that C function, passing in all my pointers and data, and it just works. It's been great. I mean, it worked once I figured out which algorithm to use. And like I mentioned, there was like a byte offset of 4. Where'd it go? It's somewhere in here.
I see it before.
There it is, right there. Yep. Without that 4, nothing works. So the first 4 bytes are, for whatever reason, don't get used. Maybe one day I'll figure that out.
Do you know what they are? What
The bytes?
do they?
No, I haven't. Once I figured it out, I just moved on. I was like, it works.
Yeah, if you read them, I wonder, because there are certain headers that you can pass in there, special cases. And I know in the Zig compiler, they look at the first 3 bytes, I think, for a specific sequence, and they'll skip it if it's there. Just
Okay.
some things, insert stuff like that.
Well, there's the UTF-16 is notorious for its bomb because it's got its own, basically its own little Indian, big Indian.
Oh, wow.
And so it has a byte order marker that's guaranteed to be in a particular order to let you know what the order of all the rest of them are.
Why does U16 exist?
Yeah, it makes me
Like,
sad.
to me, U32 makes more sense than U16.
That would have been so wasteful back in the day.
Yeah.
I think that's probably the answer.
I mean,
Yeah.
I feel like there were a lot of things that were done that were wasteful back in the day.
Like the first 6,000 encoding
Like
schemes.
JavaScript, for example.
Burn! Oh, dagger to my heart.
Just saying.
Yeah, so another thing that Zig makes easier, at least for me, is writing tests. So on the right here is an example of one of my test files from the C version I wrote. And it's not big or anything, it just requires making a new source file that has its own main function. You have to hook it up to the build system. You have to make sure you include all the right dependencies. And because this uses resources, I had to link it against all the resource data. It just took more work. And when I do it in Zig, I just go to later down on the file and I just write my tests. And it's just really convenient. So, yep, really great tests. And then another fun thing is comp time. So there's 2 uses of comp time, at least that are pretty significant. The first one is reckless Drivin uses a sign table. It stores 1,024 pre-computed values of sign. And I'm not actually aware if PowerPC, like the chips used for like those old Macs, were slow enough that this would have been useful, but I'm just assuming because this function exists that it was useful for the game.
PowerPC is a RISC variant.
Okay.
A lot of things are that. It doesn't mean much.
Well, I mean, it
Like
just
Mix is RISC, ARM is RISC, RISC-V.
Yeah,
They all are derived from RISC architectures.
yeah I'm just
x86 is like the only one that's not considered to be derived. But
Okay.
I'm just thinking 90s on an ARM processor, maybe, or like we have a lot more instructions now in that than we used to, I think, right? Like ARM is expanded.
Yeah, I mean, like it did have sign because like this uses the sign
It's still
function call.
expanding. This year-
It just pre-computes them.
This year, there are new instructions on like the latest AWS graphics instances.
Oh, wow.
You have scalable vector extensions too, so you got a lot more stuff. And PowerPC is still going to.
Yeah.
It's called Power now.
Just power? Did not know that. So yeah, and C, you have to just do this at runtime. Honestly though, it's just 1,000 values to generate. That's really not too much work. But because Zig has comp time, I was able to do it. It was trig.zig. I was able to do it at comp time, where I can just generate my sign table at compile time, and it's just nice.
I like the eval branch quota of 1,025.
Yep.
Perfect. Just the right amount of branching.
Yep. And
What does that mean?
This is yeah.
I can say anything you want, but
Go for
it's, Zig will automatically stop if you're using comp time so much, like it doesn't want you to get caught in like an infinite loop or something. So after a certain number of iterations, it will stop, and then you can increase that using that built in, so that it will just keep going.
Yeah,
Okay, got it.
that's
Makes
what
sense.
I ran into that quota, so I had to bump it up a
It
little bit.
solves the holding problem. So,
Indeed.
yeah.
That's real. That's actually noteworthy.
Yeah.
That's noteworthy that it NASA could run this. You could safely land a space shuttle on the moon without
This is
exploding.
gonna compile without running for it.
And just make sure you do the feet to meter conversion correctly. Right?
Yep.
But wait, there's not a little built-in for that?
No.
But they were missing a decimal one time, right? They lost billions of dollars.
Yeah, that was the first Mars rover or the second one.
So this is probably my most exciting use of compile time in Zig, is unpacking the resource data. So I looked at the original source code in Reckless Drivin and was able to determine, because I had the source code, so I knew what all the structs and stuff that were supposed to be pulled out were. But as you mentioned, PowerPC is big endian, and most of our computers these days are little endian. So all that data is stored big endian, so I have to convert it. So I wrote these little functions, int read, short read, rectangle read, and all these functions, and this is how I would read data from the resource bytes after they were unpacked and decompressed. And then after doing this, I would send it through another function to flip all of the bytes that needed to be flipped for the endianness. In hindsight, I should have done that in these little individual functions, but it was still really verbose, really error prone. It's really easy to forget a field in this code. And with Zig, we can just generate code at compile time to deserialize the bytes for any struct we want.
I love that.
And it's so much fun.
That's why I started with Zig. I didn't start with C.
Yeah.
You are so privileged to enjoy that.
I know I am.
So here's my my reader.
I didn't mean that in a sardonic way, by the way. I know that popular usage of that word is.
So let me pull in a use case I have for one. Let me try to remember where I have one. Okay, and here's an example. So this is loading sprite data, given some sprite number, which in this case is index. So it gets the bytes from one of the packs for that sprite as data. So data is just some bytes at this point. And then I pass it to my reader. And my reader is replacing all of this code. Where now in my reader, I can just say, hey, give me a U16 or another U16, or read me an entire slice of data of this type and use this allocator to allocate it. And that needs to be allocated because the bytes have to be flipped for endianness. Otherwise, you can just read it directly from data.
Okay, yeah.
But that's one example. This is a more straightforward example where there really isn't, and I didn't just pass sprite directly to my reader or read sprite because I have to skip some bytes because there's some data I don't need, and there's reading the slice. So this one's a bit more complicated.
This looks totally different from what I was expecting, actually. Did you write your own reader?
Yes.
Okay.
Yeah, I'm not
So-
using the Zig library
Zig,
ones.
That's the one that's built in, and you can pass in whether you want little or big, and it will flip it for you.
Yeah, I'll probably use that at some point.
You just like the hard way.
It was fun. I'm trying to remember.
Yeah, I noticed you're using try, so those can error. Okay.
Yeah, they can error. They actually never do because the bytes are constant. So I guess the only case it would fail is if I'm running this on some weird architecture where it doesn't support unaligned reads.
Well, if you were doing that, the compiler would admit individual byte reads and put them together.
Oh yeah, that is right.
Don't worry about that.
I'm trying to find another good use case where I have one of these packs.
I actually still have
Yeah,
this
that's fine.
proposal where you can specify the alignment of the pointer and then where it ends, the alignment of that, so that we can more efficiently, we could do 2 aligned loads and combine them, do a shift and more them together so that you don't have to do 8 byte loads and put them together to do an 8-byte load, because that's what the compiler will do.
Okay.
Because it has to, otherwise it could run off a page and faults if it doesn't, so.
Gotta make that suggestion.
Yeah, we gotta get that.
Here's another example of the the reader. So this packs.get entry function, given a struct, so in this case a level header, which looks like this, just a bunch of data, and they're all aligned to 1, and I don't remember why I had to do that, and later on I think I'll try to find a better way to do it, but this works for now. But yeah, you just pass the type you want to this function. Internally it uses that reader I wrote with the type, and it returns it parsed.
Is a line relative to the type, or is it just absolute?
A,
Byte. If you say a line 1, is that byte aligned, like just, it's any pointer?
oh yeah, line
Or
1.
is it relative to the?
It basically says the data is aligned at the byte level.
Okay.
So basically there's no alignment.
Okay.
Yeah.
So basically it's just anything.
Yeah.
And you put it there just for fun.
I originally didn't have this, and then I've gone back and forth. I've written it without this, and I've written it with this, and it's been a couple of years at this point. I don't remember why I chose this. I'm sure I could look through my Git log and remember why I did this, but at the moment I don't remember.
I would like to know, because that seems pretty weird to me.
Yeah, it is weird. I was looking through it the last week, and I was like, I forgot I did this
Will you do a quick
in 2023 March.
git blame on that file?
The last time I changed this file was an update for Zig. Git blame levels. So I guess there's the commit. Yeah, I don't. Okay, it looks like a change in Zig is what forced me to add it, and I think that was just the easiest solution at the time. And I'm sure there's probably a better way to do it at this point. That's my best guess.
Okay, so, but the reason that you need the alignment is because you're going to extern it because it's going to be used by other C code.
Not that. The reason why it needs to be aligned to 1 is because this is just arbitrary binary data,
Yeah.
and it has no alignment. And so I'm going to be,
Everything has an alignment of 1,
well,
right?
yeah.
So I feel like you don't need to have it there.
Yeah, I just remember I had to add them for compiler upgrade reasons, and I haven't bothered to look into it again for the last year. So, but now that you've brought this up, I think I know what I'm going to go do now.
Yeah, Control H and delete them all. See if it still works. It should. It just aligns it to 1 byte, right?
Okay,
So
we'll
I
try.
feel like-
We'll
I feel
try
like
this.
that's nothing.
We'll delete the ones for the road info and see what happens. Okay.
Yeah, it
Looks
does-
like that must have been a temporary thing in the compiler.
Yeah.
Because I added them for a reason. I at least, I hope my past self added them for a reason. Maybe I just was going crazy that day.
Are you doing malloc?
Doing what?
Are you doing
Malloc?
malloc? Yeah.
No.
Oh,
Oh, are these
alignment?
logs right here? I think these are the logs from raylib.
Okay.
So I don't know what raylib does.
Um,
I was playing with some of the new allocators that people have been working on recently.
Okay.
Yeah. Pretty cool.
It is pretty cool.
Oh,
Yeah.
yeah, I think your night shift turned on again.
Oh, did
Not that
it?
it matters at this point.
Ah, okay. We fixed it. So yeah, it's just nice to have my little reader, and I could probably use something else, but I had fun writing it and learning. But just given any type of these supported types, it'll output the data. And when I first wrote it, I was actually pretty interested, so I threw it in the compiler explorer, and just to see like what it would output. And so I threw my code in there, and then I just parsed this simple little data struct. Oh, this is probably really small for y'all. And then I used the reader to read the data. And if I remember, it's this right here. This is the output assembly for actually reading that struct. So it compiles down pretty well. So like doing a byte swap and moving data at the same time, so it can convert the endianness. So it was pretty cool. And you can tell when I worked on this, Zig 0.9.0 was the version. It's been a while since I made that link.
That's fun.
Yeah, it was kind of fun to just see that, like, even though I was using some compile time metaprogramming and it generated a lot of code with optimizations, it still gets really optimal. Just loading the
What's
memory.
That bottom instruction?
This one?
VCB, yeah. What the heck is that? Okay, yeah, that makes sense why I understand.
Yeah,
That's crazy.
pretty fun.
I thought I was a programmer.
So,
Then I came to the Zig table.
but not everything's perfect.
You're welcome.
Let's talk about what I don't like. There have been a few things, actually just one really big thing that's been a really big struggle for the last year with my rewrite, and it's safety. Int from float and float from int in Zig, or actually, yeah, those are the functions. I'll just show you the code. So Reckless Drivin, like Jonas, this guy who wrote it, as far as if I remember right, I read some interview from him. He was like around the age of a high school student, like just kind of teaching himself, having fun, making a game. And so the code's awesome and it works well for what it is, but it's also like written exactly for what it needs to be, and it's kind of a mess. And so let's just jump over to the rendering file and show you the mess. So basically every code that does rendering in the C version just does a bunch of implicit casts between floats and ints. Like every function has tons of them. And so because Zig is very explicit, I have to add the float from int and annotate the type everywhere. And some functions are better than others. Like this one, it's pretty readable still. This one's fine. But there's some down here that get pretty gross. Like there's just so much going on.
Do you have to have it like that? Like, could you just make it an actual float and not have to convert from an int every time?
The game is taking advantage of truncation. So like what this code's doing, the best I can tell, it's pretty opaque in the C version as well. But it's using like, let me try to find the variable names, like dx, dy, du, dy, y. So what he basically did was he wrote this rendering engine for his sprites that could draw sprites not aligned to a pixel grid. And it could handle it at different zoom levels and at different rotations. And it's basically doing UV mapping of the sprite. So basically given a coordinate and a rotation and a zoom, take the sprite and project it to that location. And it's trying to do it without like losing detail and all sorts of stuff. So right now I'm working on getting the sprites to render, and I'm having a lot of issues with it. But it's been fun. I have some debug print statements in there. But if we look at the sprites file, there's some more fun stuff in here that I've been working through. So yeah, so overall Zig has been really good, but there's also been a lot of frustrations with this where I'm writing this code and then I'll be running it and then it will just stop my program because it went out of bounds, or there was a float that got converted to an int and was lost precision and lost some values, and so Zig's safety says, I'm going to stop the program for you. And so in my debugging, I've had to set runtime safety to false so I can get the function to even run. And sometimes it's an error on my part in my translation, and sometimes I don't know yet because I'm still working through it. So it's been interesting. So this isn't like an inherent limitation in Zig. I think if you were writing this game from scratch, you would probably go about it a different way, or maybe isolate these kind of changes into a more isolated function and use them elsewhere so that way you could keep things more readable.
So this is more of a port than a rewrite. You're
Yeah.
trying to do a very faithful
Yes.
port.
Yeah, as much as I can. Like, I've changed a lot of things. The game makes massive use of global variables. Like, almost everything's a global variable in the original game.
As it should.
And
be.
there
How could
are
go wrong?
I have a file called g.zig, and I have a lot of global variables in here because there's just some things that get used in so many random places that I don't even want to think about where I need to store them to pass them around correctly. So I just have a bunch of things that are globals, and they probably will always stay that way. Maybe I'll change it, but there's a lot of things that I've moved from globals. But
Well, in Zig, every file is a struct.
yes,
And so if you have a global in Zig, you can just do, well, g.that.
yep, and it works well enough.
It's way cleaner.
Yeah.
Way cleaner than in C,
Yep.
Yeah.
where everything's just polluted everywhere.
So yeah, it is more organized. I really like it overall, but those casting basically, the safeties just not been nice to me. And let's see, I did disable, since we're here and we're just messing with things live, why not? Let's bring this back and see what happens. Okay. I think I still have that function disabled somewhere.
Hey, your mouse came back.
Ah, there it is. Draw sprite layer was disabled. This might crash, this might actually run. Okay, see, it crashes. And I'm getting attempt to cast a negative value to an unsigned integer.
What was
So-
doing in the original?
In the original game, source code?
Yeah,
Or-
like what did the original code say
Look,
to do?
like what's it look like? Let's pull that up. Reckless driving.
Can you find like the piece of code that was equivalent in here that just errored in their Zig version?
Wait, I have this locally. What am I doing? There we go. Yes, and so that's what I'm doing. Like I'm comparing them these side by side when I'm re-implementing it. And so I have the C code open,
Okay.
looking at what it's doing. And so it's, I don't know, I'll figure it out. I was working on this last week and I haven't had time to touch it since, but
Whoa, there's this other person that's got a reckless driving repo that's even ranking higher.
Whoa.
Open reckless driving.
Oh, that's
Can you
mine.
Check that out.
Yeah, I named it Open Reckless Driving at the time because that's around the same time I found Open Roller Coaster Tycoon, if you've heard of that.
No, but I've heard of roller coaster.
So some people have taken, because that game was like famously written in assembly
Right.
by like Chris Sawyer, I think his name is, and
Legend.
yeah, amazing. So these people have rewritten all the game code in C++, and
Oh,
I
that's
think-
that's in the wrong direction.
but so long as you have the original data files, which I do, because I had that game as a kid, you can just take your data files and then their version of the game and run the game. So I learned about that, so I named my thing Open Reckless Driving, just so people know it's not the original.
So have you looked at the C spec and looked at like what the undefined behavior is for C versus Zig?
No, but I think I'm at the point where that's what I need to do.
Yeah, so I can tell you a little bit. When it comes to unsigned integers versus signed integers, they behave differently. So in Zig, overflow is undefined if you use like just the regular plus, right? Whereas if you use the explicit wrapping operator in Zig, it's defined.
Yeah.
For C, I think it's undefined if the unsigned integer overflows. But for the signed integer, it's defined that it will wrap. I think that's the rule.
Okay.
And so I suspect that you are being bit by some of these things about C, where it has specific things in the specification, where in Zig, you can do the same thing, but you say that you want it to do that explicitly. Whereas in C, you just have to know about it.
Yeah.
So,
That's, yeah.
I suspect that you're being bitten by that a lot. So probably I should give you a link to it if you can't find it. But
Yeah, I will, after, 'cause I think I'm basically done at this point. So yes, please, give me a link. So I think that's it. That's the end.
Wonderful.
So yeah, like I said, there's source code and a lot of things I've written about this that go into more detail if you find any of that remotely interesting.
Yeah, I'll let you.
And I whenever I find time to work on this, I usually share what I've most recently worked on if it was useful and interesting to the world. But yeah, thanks for letting me ramble about that. That was fun.
No, that was really, really interesting.
Yeah, that's cool.
Yeah, hopefully that was like my whole point of this was hopefully just trying to show like how I use Zig in context of a real project I'm working on, and also maybe some cool history that was new to me.
That's really neat.
Like a resource forks, it still blows my mind.
Oh, that sounds
Can I-
so dangerous.
Can I say something else? About
Yes.
With like the bit shifts and stuff. So when translating between big endian and little endian, you really got to be careful with how you do that. I'm sure that you are, but I will just say I wrote one piece of code for my tokenizer, and you know my goal with it is it's for a compiler, and so this has to run big endian and little endian, and I hand wrote the piece of code that I mentioned already, where I want to do 2 aligned loads to get 1 unaligned load, rather than just doing 8 byte loads and putting them together. I hand wrote that, and the code that I had to write to do that was more complicated than if I had just written it in assembly. Like if you look side by side, the assembly is way simpler.
Oh, wow.
Because I'm like, okay, if it's little endian, then shift it this way. If it's big endian, shift the other way. And I sort of wish, in a way, I wish that we had some function or something where it will just flip it based off the endianness. Like, I understand why there isn't a built-in operator for it, but maybe I should have written a function that does it.
Yeah.
But yeah, if you look at that piece of the code, which I'll show next month, it's just like, if it's little endian, do this, if it's big endian, do this,
Okay.
and then next step, and like just keep doing that over and over. And it's tedious, but
Yeah.
it's what you gotta do when you're going between these two, and the compiler's not gonna help you out. You have to just write it.
Yeah. I will definitely have to look into the stuff you're pointing out.
Yeah.
I've considered, because like I've been running into these issues for the past year, and like getting the I don't want to get that right. Getting like the roads and everything to draw was pretty straightforward overall. That for whatever reason that code hasn't really run into too many issues. But the sprites have been a pain. And so if I can't get it to work and it's going to be too messy and too gross, I'm really considering just using the C code that exists and then just adapting it to work with the way I've redone the code.
Yeah.
Because that would probably save me a lot of time.
You know that Zig has a C translate in it.
Yes.
So
Yes.
you could look at the translation that it does
Do you think that would handle all the bit shifting more correctly than I'm doing it? Okay.
automatically too. And
Okay.
actually under the hood, I think when Zig runs C, it's doing the C translate every time.
Yeah.
Um,
Okay.
So
I will
by
definitely try
default,
that.
If you were to import C, it would do a translation, just like a one-to-one mapping pretty much. And then
Okay.
it would compile it itself.
I'll have to do that.
So that would probably make your life way easier.
Yeah.
Have
One of the
you
reasons
ever-
I haven't done that yet is like this code right here.
Yeah.
It's like G base address is like the base address of the bytes that represent the rendered pixels. And then this is just some number. And I'm not using a global number that represents where the bytes are in memory. I'm using a slice. And so this doesn't like map perfectly to the way I've done it with Zig, but I do think that's why I haven't tried that yet, but I like that suggestion because I think that would be really helpful. To just see what Zig turns us into and then I can go from there.
Yeah. Did you ever read the article on Zig.news where it said Zig is a great language for optimizations?
I don't, maybe.
If we could look that up real quick. I actually learned about the difference between the signed and unsigned undefined behavior in C from that
So
article.
Zig is
Yeah, it's on Zig.news.
Zig.news. Oh, that's not how you spell.
And then,
Zig.news.
close.
I tried. And you said,
Look at that. Yeah, look up great language for optimizations. So just type in great and optimizations, probably. There you go. So yeah, one thing that's interesting about this is, yeah, it compares two small data structures. And also this article links a talk by Chandler Caruth where he's talking about optimizations in LLVM. And
There it is.
yeah, right there. So if you look at that, the big takeaway, oh yeah, just click the link. It has
Oh.
a second.
This-
Yeah, just watch that first. Garbage in, garbage out.
I also want to give an example of optimization. There was a whole talk earlier this week about kind of optimizations that fall out of kind of narrow contracts that the compiler can make very profitable transformations based on. This one, though, is my personal pet favorite because it's one that every single compiler and optimizer engineer I have talked to never saw coming. They all knew about all the other optimization things. It's like well studied. This one they did not see coming. And this is also fairly real code. So I mentioned spec earlier. One of the applications in spec is actually fairly widely known. How many folks here have heard of bzip? Anyone? Cool. This is a function in bzip. It's actually a really tiny snippet of a function in bzip. But this actually comes out of bzip. Okay? And this is actually in a very hot part of bzip. It's part of a quadratic algorithm inside of bzip that it tries to do for a little while because it's very profitable for compression, but very expensive Okay, and so this is a very important performance-sensitive piece of code in BZIP. I also have these dot, dot, dots here. An important thing to realize is that this goes on, this 1 and then 2, we get up to 12, and then we start looping. Okay, and then we have another 12 inside the loop, and we loop for a long time. So I'm just showing 2 examples here, but this is actually a repeated pattern that happens throughout this entire function. Okay, and what we're doing is we're extracting 2 characters, right, two bytes of data. We are comparing them, and if they're not equal, then we've determined that this is greater than, and we return the greater than state. This is just a comparison function. All of this is the implementation of a sort algorithm, all right? And you wouldn't expect a sort algorithm to really suffer from optimization challenges to do with narrow contracts versus wide contracts. But this code was written using unsigned integers. And one of the reasons it was probably written using unsigned integers is to get that wide contract. Okay, to get no. Any value we use here, it'll be well defined. We don't have negative numbers, we don't want undefined behavior, we're going to use an unsigned integer. And as a consequence, we get this code on the right-hand side here. And this code on the right-hand side, I don't know if you guys read a lot of x86 assembly, but the code on the right-hand side is terrible, atrociously bad. So I'm going to skip right ahead and show you what the code should look like. So if we just take these 2 U's out of this signature and make them signed 30-bit integers, we get this instruction sequence. This instruction sequence versus that one. There's a small difference here. Okay? Now what happened? That was the immediate question when people asked me when I showed them this. They couldn't believe that this was actually that big of a problem. So what's actually going on here is that
keep watching,
we have these 32-bit integers.
Yeah, he's explaining.
And the 30-bit integers are used as array indices here. Okay? When you use a 30-bit integer as array index, right, what you're actually doing is you're taking the array, which is actually a pointer, right, at the hardware level here, this is a pointer, all right? And you're taking this index, and you're going to scale that index by some value, okay, in this case, 4, all right? Or sorry, in this case, 1, so it's easy. Some cases you have 2 or 3 or 4. And then you're going to add that scaled value to your pointer, and then you're going to dereference that to load the value. Does that make sense? Now, this is so common that x86 has a special hardware feature to do precisely this, okay? And in fact, the other thing that's so common is that you do first 1, and then you add 1 to each index here, and then you do it again. And 2 then adds 1 more, and then we do it again, and again, 12 times. And then we do another 12 inside of a loop. So common, x86 has lots of features to help you with this. You can actually add a constant offset. You can scale things. You can do all of this very nicely. But there's one problem here. If, for any reason, this +1 down here overflows, okay? In 32-bit, it has to wrap to a 30-bit number. And if that happens, right, it's going to be a very different value.
Something's
weird. This is a 64-bit architecture that I compiled the code on. So the pointers are 64 bits, but the indices are 32 bits. This happens all the time in real code, right? Because you don't need 64 bits of index. You only need 32 bits. It makes your data structure smaller. It happens very, very frequently in real code. And so in order to implement that in x86, we actually have to use a different set of instructions. This LEAL. All right, and what this L over here means is that we're restricting this to a 32-bit computation. I put it into EAX, 32-bit register. All right, this gets us the 32-bit wrapping behavior. That's all it's doing, is getting us this 32-bit wrapping behavior. Because if we got the instruction we wanted down here, if we just folded this into the address computation to load the value out of memory, we wouldn't wrap it 32 bits, we would wrap it 64 bits, because it's a 64-bit pointer. Okay, and we get a completely different answer. Now it happens that in this program, the programmer didn't need 2 to the 31 modulus behavior. That wasn't what they were interested in, right? They were actually interested in just having an integer. And so this actually slows down, this actually causes this inner loop of bzip2 to have over twice as many instructions as it needs to, just because we used an unsigned integer when we didn't need, that extra precision. We didn't need modular arithmetic, but we were a little bit worried about a narrow contract, right? Narrow contracts are simpler. They do actually allow you to make very impactful transformations. It's not just about loop analysis or other things.
So I think that's
All right.
the point.
Sorry, any questions about that?
Yeah, that's what I was talking about.
Okay.
So you can be bit by this kind of thing, especially when it comes to grid, which is going to automatically ensure that you're abiding by the contracts that you set. But then in the C language, it has a different set of contracts like this. And so when you translate C contracts to Zig contracts, where you can see them explicitly in Zig, and in debug mode, Zig will say, oh, you didn't divide the contract, then you can hit that a lot.
Okay.
And I think that's a good thing about Zig, but it can make it difficult when you're manually translating
Yeah.
Zig over to Zig.
Especially
Because
nasty
you will-
code like this.
You will get bit by not understanding how C works. So you have
Okay.
to understand both languages in order to do a really good for it.
Yeah. And I figured it was something along these lines, but never this much. So thanks for bringing that up.
Yeah. Also, like you said, this has a lot to do with efficiency too. In that article that I mentioned, talks about, it's like, oh yeah, well, one of the lines that Chandler Cruz says, maybe he would have said it in about 30 seconds, but he's like, people like to use the unsigned 32-bit integer to like steal that one extra bit, so they can go a little higher on the indices. But that is no more. You shouldn't be doing that anymore. You just use a signed integer because that's what you have to do for the contract that is provided by the unsigned versus signed in C++. And in the article, the guy's like, well, yeah, I want that last bit. That's why, like, if I was writing in C++, that's why I'm writing in a low-level language, is because I want to be able to do that. Otherwise, I would just write it in Python or something,
Okay.
But in Zig, you get the best of both worlds, because you actually get to decide what behavior you want, and the language itself makes it clear what that behavior is, so. Whereas with C, you just imagine that you understand what's happening, but you didn't read the spec, and so you don't actually know. So,
Yeah, I'm guilty.
I'm going to say one more thing. I've seen a piece of code one time. I can't remember where it was right now, but it might have been one of the Sydney libraries I've read. But I saw a comment where they said, oh, Dr. John Roger at the University of Utah signed off on this, that this is okay to write in C, that it will have the semantics that I think it will. And it was just for I think it was for a signed redshift or something. It wasn't even something that's like really out there. But it's just funny to me because it's like, what does this do? I don't know. Let me ask someone with a PhD if they think it's okay. Like, that is so silly to me. But yeah.
It's so interesting. That's fun.
You shouldn't need a PhD to understand your language. That's crazy. That's one of the reasons why I don't want to use like CMake or, I think in some ways like you have to use build tools sometimes that are going to be convoluted, but
Yeah.
I don't want to get a PhD in CMake. I don't want.
Yeah.
I don't want to do
I've
that if there's any other way.
I've dug through Blunder's CMake file a couple times to try to fix things, and it was just such a mess. Not file, I should say files, because there was just tons of them, and it was just a mess. It was fun.
Yeah, a lot of the more modern tools, I think, are a lot better where it's like, you have things that are made for like CI and CD that you can run on your local machine. And if it works on your local machine, then it's going to, work when you actually send it out.
Yeah.
And like, I can't imagine that, like, people have lived without those types of things. Like, you just kind of pray, and then it's like, well, hopefully it works. Let me just send it out. I think it'll work. I don't know. I don't want to do that. So. Yeah. Hope is not a strategy, in my opinion. So.
Fun. Well, I'm sad I will be missing your optimization, but I will watch the recording.
Yeah, apparently your vacation is more important.
I'm sorry.
Me and AJ, one time.
Amen.
No, I will watch the recording though, because the last one was super interesting, and I missed that one too. I watched it from home live. I was sick, so boo. I know.
All right. Well, I will go ahead and end the recording and the stream here.
Cool. end it on the note of me talking about illness.
Yes. Illness for the win.
Usually AJ ends with like how we like a world war or like zombie apocalypse or
Okay, let me.
bombs. Mass
So-
deaths.
I watched World War Z and Moonfall and A Quiet Place Part 2 in the same night. Well, I was listening while I was coding. So I did miss some of the parts of Moonfall because that plot made no sense. A Quiet Place was really, really slow, so you can get the whole plot without like intensely watching the movie. World War Z was basically both World War Z is Sharknado with Brad Pitt and zombies, and Moonfall is Sharknado with a $124 million budget that doesn't look particularly better than Sharknado.
That movie doesn't look great.
Yeah, the Moonfall was pretty bad. But the good news is that in all three of those movies, there's a massive, catastrophic deletion of human life that will help towards the rebuilding of a better society. And